This podcast is presented by SCHOTT. With over 130 years of experience delivering innovative, high-quality products, SCHOTT is the global leader in specialty glass, glass ceramics, and other innovative materials. With a direct presence in over 30 countries, the company is a highly skilled partner for several high-tech industries, including defense, semiconductors, data communications, optics, energy, automotive, aerospace, and healthcare. One of SCHOTT's key goals is environmental protection corporate-wide, and it is committed to being the first specialty glass manufacturer in the world to be climate neutral by 2030. Thank you again to our sponsors at SCHOTT for helping us present this podcast to you. Hello, and welcome to the Emerging Tech Horizons podcast. I'm Mark Lewis, Executive Director of NDIA's Emerging Technologies Institute. And on today's podcast, we're going to focus on the applications of glass materials across the board in emerging technologies. To help us explore this topic, I have two guests, including Bill James, who is the Vice President of North America R&D for SCHOTT North America, and Jesse Bonfeld, who is the New Ventures Business Development Lead for SCHOTT North America. And let me tell you a little bit about their backgrounds before we begin. So, Bill completed his bachelor's and PhD degrees in chemistry from the University of Scranton and then Purdue University, respectively. James's doctoral dissertation research studied single conformation spectroscopy of foldamers. He expanded on this work by applying his physical chemistry expertise in postdoctoral research on molecular conformations in supersonic expansions, a topic near and dear to my heart. James's 12-year professional career at SCHOTT North America began as a product development scientist, contributing new products in seven different application spaces. Worked his way through several promotions to become vice president of the research and development and the New Ventures team. Current responsibilities include strategy development, program management for the U.S. Growth Program, and of course, heading government relations. Also joining me, Jesse Bonfeld received degrees in chemical engineering and biochemistry from the University of Arizona, and for over 30 years has served in business development roles across a broad range of industries, including semiconductor, aerospace, oil and gas, specialty chemical, and medical devices, with a constant focus on advanced manufacturing solutions, primarily for the Department of Defense and DOE customers. More recently, he worked in the Tech Transfer Office at Sandia National Laboratories. Jesse has also authored several articles in various trade publications on the application of existing technology and product innovations to new technology challenges. In his current role, he is managing the SCHOTT New Ventures team product and application development efforts with the federal government. So please join me in welcoming Bill and Jesse to today's podcast. And I'm looking forward to exploring all things related to glass and its applications to emerging technologies. So gentlemen, let me start off by asking you if you could tell us a little bit about your background. And Bill, if you could start.
Sure. Thanks, Mark. So my background is in physical chemistry, as you mentioned, and I started out really engaged with gas phase molecules and their molecular conformations, and took a quick sidestep here to the solid phase, or the amorphous liquid phase, if you will, that's frozen, which becomes this marvelous medium of glass. And for over the past 12 years, I've looked at different emerging technologies in infrared materials, fiber optics, porous materials, glass-based porous materials, that is, looking at things that are focused towards chromatography, thermal protection, desiccant for lasers, and other applications there, as well as laser glass and traditional optical materials.
So I have to ask, in your biography, I mentioned that you did a spectroscopy of foldamers. I have to ask, what's a foldamer?
Foldamer is a coined term for a non-natural amino acid. So it's a building block similar to proteins, and you look at how they fold and their conformational preferences can give us insights into our biology and potential drug development to come up with new designer medications for plenty of indications out there that can help human nature.
Excellent. Thank you. Let me turn to Jesse. Tell us a little bit about your background.
Sure, Mark. So as you said, degrees in chemical engineering and biochemistry. Interestingly, though, I've never really been a fully practicing engineer. The year I graduated was a bad year for chemical engineers. And fortunately, I had worked in industry through a program that was sponsored by the university, mostly in the oil and gas industry. And when I went to go for a job, one of the vendors that I had dealt with over the summer offered me a position, and it was a sales position. And I never thought about being in sales. I never thought about whether or not I'd like it or be good at it. but fortunately, as it turned out, I did like it and I was pretty good at it as well. And so my entire career has been focused on technical products in a business development or sales role. And for about the last 15 or 20 years, my customers have primarily been with the federal government and usually Department of Defense. So it's a roundabout way to getting to where I am now. I started with SCHOTT a little under a year ago, but I'm really enjoying the opportunity to kind of expand my product knowledge and apply it to DoD applications.
And I love the idea of someone in your role in applying both technical skills and sales skills.
It's very rewarding.
Very
really
good.
Enjoy it.
So let's talk about some of those rewarding aspects of it. I want to do a little bit of a deep dive on some of the innovative projects that you're working on. So let me toss that over to Bill.
Mhm.
Can you tell us a little bit about some of the innovative projects that you're working on?
Sure. There's actually quite a few here. In the U.S., with our research and development team based in Duryea, Pennsylvania, we're working on a porous material that goes into coatings for hypersonic vehicles. We're working on infrared materials, so chalcogenide-based materials for identification and night vision applications. We're revolutionizing the night vision industry now with I-squared technology that's lighter and better transmitting than prior night vision inverters and I-squared technology. And we're also looking at laser glass for both range finding as well as high-powered applications.
Excellent. I'll try to do a deep dive on some of those topic areas. By the way, I just want you to know you had me at Hypersonics.
Excellent.
So Jesse, anything you want to tell us about innovative things?
Sure. So there's, Bill focused a lot on what we're doing with the government and with DoD. And to expand on that, we have a product that's used in directed energy applications, and we're looking to try and expand our footprint on that platform. We've recently had some engagement with some DoD entities looking at quantum sensors, which is another very interesting area that we're trying to pursue, and looking forward to working with them. And then finally, solid state batteries. One of the DoD research entities has reached out to us. We have a fairly novel material for a solid state battery application. And one of the things that makes it novel is the way we process it. The material itself isn't necessarily novel, but the way that we process it allows us to impart some properties to it that are somewhat unique. And that's what DoD is interested in. So a lot of very cool stuff happening, fun stuff. Working both with the folks here as well as folks in our Germany home office. So that's another thing about it that's very interesting.
Very good. So I'd love to do a kind of a deeper dive in some of those applications that you've both mentioned. Can we start with hypersonics? Not that I'm biased, but Bill, could you give us a little bit more details about some of the applications for glass and emerging technologies such as hypersonics?
Sure. The product I mentioned earlier is coral pore porous glass, and that is a nanoporosity or a nanoscale pore size porous glass that's high in silica and low in other materials such as mixed metal oxides, alkaline earth, alkali, to keep that as robust as possible for high temperature environments. So think hypersonics, think reentry vehicles. It's really a time-tested, proven thermal shield.
And I can expand on that a little bit. One of the things that we've come to realize in the hypersonics realm is that there are some materials that are needed for the ultimate high temperature that the vehicle or the platform is going to experience. However, not all of the acreage of the platform experiences those ultra high temperatures. Those materials that are able to withstand those ultra high temperatures tend to be a little bit difficult to get. They tend to be a little bit expensive to acquire. I believe there are some issues with the supply base, the industrial supply base to support them. So our thought is, and our feeling is, that the material that Bill mentioned, coral pore, could be used on some of the surfaces that do not have to see those super high temperatures. And that's what we're exploring now with the Army and with a couple of tier ones. And we're really looking forward to them getting this material, doing some more testing on it, and seeing whether or not it really can apply itself and maybe make the application a little bit easier to solve.
Excellent. We're actually at ETI. We've done a supply chain study. It's actually going to have 4 pieces to it, but the first will be on hypersonics and looking at some of the issues associated with high temperature materials, and agree completely that it's something that we have to pay attention to. Especially if the department is truly serious about producing in scale. It's not just the 1 or 2 demonstration flights, but producing sufficient quantities at low enough cost so that these systems are affordable.
And one of the other things about this particular material is we know how to make it. We can make it in copious quantities. It is relatively inexpensive compared to some of these other materials, and it's made domestically. So we think we really have a potential good solution that we want the DoD to look into.
Does your work have applications to sensor windows as well?
So sensor windows, not this material, but yes, actually we do have some materials that could be used for sensor windows. We're engaged with a vendor to DoD right now who is talking to us about that particular application. We just had to go through getting the distro D approval in place so that we could talk to them openly about it. But again, we're very interested in that application. And one of the other good news stories about that is the facility here in Duryea, Pennsylvania, that would be working on that does ITAR work, has done classified work. And so if it gets to that point, we can certainly participate. It's not going to be an obstacle.
Excellent. So the second part of the ETI supply chain study is going to be focused on directed energy, and you mentioned earlier that your work is obviously applicable to aspects of directed energy. Could you talk to us about some of that?
Sure. So right now, one of the products that SCHOTT manufactures is a product called ZeroDur. It's a glass ceramic material. It's been around actually for the better part of 50 years, has been used in numerous space applications and high energy applications. The reason being that it has a phenomenal CTE, coefficient of thermal expansion. So it basically can operate over a very wide temperature range and not alter its physical, the CTE doesn't change. So right now, it's being used as the substrate material for the primary mirror on a couple of DoD applications for directed energy. And there are other optical components that SCHOTT manufactures and other capabilities that we have around coatings and maybe even modifications to the various forms of ZeroDur that we think might be helpful to expand to these DoD applications for directed energy. So we're talking to the Navy, we're talking to the Army, and we're really, again, looking forward to doing a little bit of a deeper dive on what these materials can do and what the applications could potentially be.
Very good. Pretty good. You mentioned batteries. So batteries is not usually identified on its own as an emerging technology, but it is so fundamental to so many of the emerging technologies we're looking at. It's such a critical issue for the Department of Defense. Tell us a little bit about how glass technology applies to solid-state batteries. Right.
So in this case, again, we're looking at the way that we process the material as opposed to necessarily the material itself. Solid-state batteries, the applications for DoD kind of run the gamut from envision the battery pack for a dismounted warfighter to batteries that need to be on platforms that need to sit on the shelf for years and years and years and years until they might need to be used, and they have to be fully charged, so they can't discharge just sitting on a shelf. That's actually the application that appears to be most of interest to DoD right now. And one of the elements of the way that we process our materials is that we put it through an amorphous phase, which basically improves the homogeneity. And so that then tends to make these materials a little bit better suited to this particular application that the DoD has expressed interest in. And again, this is a situation where these materials can be manufactured in fairly large quantities, relatively inexpensively. We've actually just completed sending some samples to one of the DoD agencies to have them tested a little bit more extensively, see whether or not it really meets their requirements. And it's an excellent O&R program, and we're hoping that within a year or so we'll have some definitive answers as to whether or not this material can really solve some of the problems.
Are there commercial spin-offs as well?
There will be commercial spin-offs, we imagine, and we expect. We are working with some entities that are looking to supply the EV market, the electric vehicle market. It's interesting though, because those are obviously super high volume, um, much more price sensitive situations, whereas we envision the DoD application to probably be lower volume, maybe not quite so price sensitive, but we're very pleased that we're looking at supplying really, I mean, I'd call those both ends of the spectrum of the solid state battery market.
Right.
So,
Yeah, absolutely. And also, I'm thinking in terms of just supply chain, supply sources. We worry about domestic sources
mhm.
of batteries, and it sounds like that's also a factor here.
It absolutely could be. Yeah. Right now, that material that we're talking about is not manufactured domestically. But again, if the demand signals exist and the business case exists, then we'll look to try and bring it over here.
Very good. So, Jesse, could you tell us about applications for glass in semiconductor packaging? And recently we had the CHIPS Act, which was passed. Obviously, microelectronics are a big issue. So, where does glass play a role?
So glass actually is already playing a pretty significant role, primarily in semiconductor packaging. There are a couple of smaller companies here domestically that have done some really amazing work in figuring out how to integrate glass as a substrate material. It has a lot of potential benefits over silicon. And the CHIPS Act specifically, we're looking at the opportunity for a new MMI, a new Manufacturing Innovation Institute, to be stood up. We're currently speaking to a couple of entities about trying to form a team around advanced packaging and potentially looking at glass specifically. There's a lot of great opportunities here. A lot of the basic research has already been done, and so this is going to fit it really well into the MMI model, where you're looking at more of the 4 to 7, the applied research element, and then transferring over it into high volume manufacturing. So yeah, we're very excited about the funding. We see that it's a great opportunity to take a material that has been looked at and looked at and looked at, and look at it a lot deeper, and with a lot more detail to really see if it's applicable.
All right. So fascinating application. I have to tell you, what I'm intrigued by. I mean, glass originally is such an old technology, really, but to see new capabilities, new applications, especially across the range of DoD emerging technologies, I find that really quite intriguing. That we're still learning things about this material.
Right, and I think it really speaks to one thing about SCHOTT that a lot of people may not be aware of, and that is we're really more of a materials company. We certainly started out as a glass company. The people that do know us as a glass company. But when we start speaking to them about the idea of being a materials development company, then their ears and eyes start to really perk up. Because if you look at the applications of these materials and what you can really do with them, it's so overwhelming almost. I mean, there are all of the consumer applications that I think a lot of people are aware of. Glass fireplaces, architectural glass. But then you think about the Saran cooktops. That's a SCHOTT product. So that's another interesting consumer area. Then you look at, as you said, with semiconductors and glass as a substrate. You then can take a look at the space applications. We've been on an enormous number of satellite programs. Most of the really high-end and really far-reaching telescopes that are out there have SCHOTT products in them. They've been enabled by SCHOTT. If it wasn't for the SCHOTT products, they wouldn't be able to do what they can do. Moving forward, you can also now see things like what's happening, the Lawrence Livermore NIF facility. Number of SCHOTT products in that is enormous. Fusion energy. There are opportunities in fusion energy now where we could see glass and glass ceramics having a major impact. So, as part of the R&D organization, this is one of the other things that I really love about what I'm doing. For an R&D organization to have a business development arm, it's really pretty unusual.
Yeah.
And I'm just one of 4. I have 3 other colleagues that are in a business development role for SCHOTT R&D, who are looking at other parts of the marketplace outside of DoD and government, which is my focus. And again, you're talking med tech, semiconductor, some other consumer applications. The med tech one is really a very interesting one because we're talking now about the ability to put things onto glass or imprint things into glass or dope glass that allow the product to maybe be an implantable. So right now, titanium is obviously the preferred material for implantables.
Right.
Well, titanium is really expensive and not the easiest material to work with.
Right.
What if you could do those things with glass? And we're investigating that. So a lot of really exciting things happening. And again, being part of an R&D organization in this kind of a role, I'm having way too much fun.
Thinking you could actually do a glass jaw.
Well, who knows? Stranger things.
Yeah, exactly.
So, but
exactly.
we're not limiting ourselves to what's been done. We're looking at what could be done.
So one of the things that I also find intriguing. So your organization obviously has a robust commercial business, but now you're also supporting DoD, getting involved in some pretty significant, hefty DoD programs as well as DOE. So we're always interested here at NDIA at companies at all places in the defense industrial base. From your standpoint, could you give us your sense of the health of the defense industrial base and what steps could DoD do to support a company like SCHOTT?
Right. So I'd say that the industrial base is in relatively good shape. I think really the question is not necessarily what is the health, but how much better it could be. It's kind of a sliding scale. What are you interested in, where you're at, or where you could be? I think there's certain things that DoD probably could do to help the industrial base. Not only SCHOTT as a fairly large company, but really the smaller companies, the startups that are looking to try and reach out to DoD, because as you know, a lot of innovation happens, in the lab, and the lab gets transferred into a startup, and then the startup becomes big, and everybody's happy. But that pathway is tortuous at best. So certainly one of the things that I think would be helpful would be clearer demand signals. And you've heard this before.
Yeah.
This is something that a lot of people have been talking about for a lot of years, and it still needs to be talked about, because without the right demand signals, we can't justify making the investments that are needed to support DoD and these really, really critical programs, not only for our national defense and our national security. These are important programs that need to move forward. Demand signals is a really important thing. I think one of the other things that could happen that DoD could do to help us is be a little bit more forthcoming and a little bit more accessible when it comes to having the critical technical discussions. So, you have to really, in some cases, dig deep and dig long and dig hard to try and find the right people to talk to, make them aware of your capabilities, and then have those kind of really salient conversations. Fortunately, SCHOTT is willing to allow me to do that.
Right.
Again, which is sort of unusual for an R&D organization. A lot of companies aren't patient enough to do that.
Yeah.
They're looking at answering to the stockholders next week, next month, next year. I fortunately do not have that constraint, and that allows me to be a little bit more flexible, have somewhat longer time horizons that I'm looking at, and really try and get the job done. Ultimately, both for SCHOTT and for DoD. We're looking at Horizon 2, Horizon 3. We're looking way out there. So that's kind of our mindset, is this 2, 5, 10-year mindset. Anything DoD can help companies to allow them to look on those kinds of timeframes, because that's the kind of time frame they're looking at.
Right.
That would be really
helpful. No, I absolutely resonate on your point about having a clear demand signal, also a consistent demand signal, as you point out. If the priorities change every time a new person gets into a position, it doesn't serve industry very well. So you're also in the interesting position of being a North America organization, but you got ties back across the Atlantic. Does that pose special challenges for you?
I like to think it actually poses some interesting opportunities.
Good.
To tell you the truth. Of course, there are challenges. There are logistics challenges, and when you're talking about working with DoD, you have the ITAR issues and disclosures and things like that. But realistically, I think there are a lot of opportunities. If we get clear information about what it is that's going to be needed, we can make the necessary investments here domestically, and we're willing to do that. But there has to be some support. I know that there are lots of organizations within DoD that are going out there. They're investigating the industrial base. They're trying to gauge where it's at, where it needs to be in order to support DoD, and then what's it going to take to get it there. Does that mean that DoD has to make a direct investment? Maybe it does. Does it mean that DoD can invest with the company to get to where they want to be? That's another option as well. And if there's enough of a clear demand signal, the company itself might be willing to make that investment. But all of that is all good stuff. It does make it a little more interesting when you have an overseas-based supplier.
Mm-hmm.
But the good news is we've got this great history of supplying DoD not only from North America, but also directly from overseas. That's something we currently do and something we certainly would like to do more of. So the communication is critical. The open conversations need to happen. And, fortunately, I think DoD is getting better in that. I mean, I've worked with DoD for more years than I like to admit to.
Yeah, we won't hold you to the number.
We won't go there.
Yeah.
But I think they're getting better at it, and I think there's more of a focus on it. And interestingly, I think especially with some of these programs that we've talked about today, the urgency is all of a sudden boiled to the top for reasons that we all understand. And that's kind of pushed DoD maybe to accelerate some of these things, accelerate these conversations, put people in DoD who have the knowledge to be able to go out and reach out to the industrial base and engage them. I've attended several events here recently where that level of engagement is obviously a lot more open and I'd say a little bit more intense than it used to be, but that's a good thing.
Yeah, no, we're certainly seeing that here at NDIA. More opportunities for our member companies to engage, and we're seeing strong interest from the Office of the Undersecretary of Defense for Acquisition and Sustainment, Bill LaPlante, as well as Office of the Undersecretary of Defense for Research and Engineering, Heidi Shue. So you mentioned overseas suppliers. There's a lot of interest in onshoring. What are the specific challenges and opportunities related to onshoring of glass production and processing?
Right. So there is some fantastic opportunities, really. One of the things for SCHOTT specifically is that we have expansion capabilities at our existing facilities. So it's not like we have to do a greenfield to create some of these additional capacity and technological capabilities. So that certainly is a big plus. The other thing is, again, from a corporate management perspective, this is something that we're talking about, we've talked about before. We have support at the highest levels of the organization to do this. If the business case exists, it'll happen. So there just has to be a good justification around the business
So
case.
Back to your point about need a demand signal, it needs to be
So
consistent.
critical. It's so critical, and it's really the only way that that these things are going to happen. I think one of the other issues that from being a sub tier 1 supplier, I don't know if you want to call us tier 2, tier 3, call us whatever tier you want. But one of the other things that's critically important is we need to get the demand signals from our customers who are not, DoD is not probably going to be our customer very often, maybe sometimes, but it's usually going to be a tier 1 or a tier 2 contractor. They need to give us the demand signals when they get their demand signals.
Right.
And that's, I think, historically something that vendors at our level within the supply chain have always struggled with. Our customer will get an order, and then 2 years later we find out about it and they want us to deliver in 6 months. That puts a strain on our capabilities.
Right.
And it also, you've then missed that 2-year window to be aware of what the demand signal is, to maybe make investments that might have made the delivery 2 months instead of 6 months.
Right.
So that's another element that I hope the tier 1 and tier 2 community hears and is listening to and recognizes how important it is.
I love that you made that point. So we've often had the discussion here at ETI as to exactly who our audience should be. And people often say, well, it's obviously government, it's in the Pentagon, it's on the Hill, it's in the executive branch. I've said yes, and it's also industry. So that industry knows where to make those investments and also knows how to issue the demand signals to their industry partners to meet the needs of government.
Absolutely. And the more that NDIA can do to bring in those people and bring them together and have that conversation, I've always found NDIA to be an extremely valuable organization to be involved in. But the more you want to add to your value, the more you can do that, the better.
Absolutely, absolutely. Bill, James, any last any parting comments before we wrap this episode?
No, we appreciate your time today, Mark, and thanks for bringing SCHOTT North America to the forefront here of your audience. And we'd like to see how our technology can really change the world and benefit the DoD, and see how we push forward with the help of NDIA.
Thank you. Bill James, Jesse Bonfeld, thank you so much for joining us. Thanks to SCHOTT for providing you to us. Thanks for the great work you're doing on behalf of the DoD. At the end of the day, that's how we're gonna win. That's how we're gonna win, bringing all the resources of our defense industrial base together. So,
Absolutely.
Thanks for your time.
Thank you, Mark. We appreciate it.